Hello, my name is Clemens, I'm the CTO of Persival, and this is our weather test bench. With this test bench, we can take automated measurements in challenging weather conditions like rain, snow and fog. And the benefit here is we can measure the actual real-world conditions because obviously we're outside. So we measure the actual weather that we have in the real world. In order to do that, of course, we need reference measurements. That's what we have these weather sensors for. This one can measure the general present weather conditions. So we can measure the rain intensity in millimeter per hour, we can measure illumination, temperature, humidity, wind speed, wind directions, and so on. And then we have more specialized sensors like these ones. Here we measure the meteorological optical range, so basically the visibility that we have in fog. And here we can measure the actual drop size distribution of rain and snow. And that's quite important because the drop size distribution plays a big role in how optical sensors, like these lidars here, react to these weather conditions. Speaking of these lidars, in front here we have our perception sensor area. So here we can mount several perception sensors. And they are aimed at a target area that I will show in a minute. And we also have a lot of free space here. So we can measure both the reaction towards a target, but also the reaction of the sensors in free space where you will get reflections from raindrops directly, for example. So now let's head over to the target area. On my right side, we have a calibrated reflectance target inside a protective housing. So whenever we take a measurement, a cover goes up and you can see inside we have a Lambertian calibrated target. So we know its reflectivity and therefore we can compare it to the reflectivity and the intensity that the sensors measure during certain weather conditions. And on my other side we have typical targets, highly reflective targets that you would find in a normal road environment, to have the difference between a lower reflecting calibrated target and these highly reflected retroreflectors. And the measurements are taken automatically, so whenever there's a certain threshold passed in the reference sensors for a certain rain intensity, a certain visibility in fog, a measurement automatically starts. So you can take automated measurement over a period of months to get a lot of different weather conditions. And the location we have here is actually quite good. We have a lot of fog here, we have a lot of rain. So you can measure all sorts of conditions with the atmosphere, but also with dedicated targets like we have here in a certain distance to the station. So now let me show you what a measurement with the weather test bench actually looks like. What you see here on the left is the point cloud of the connected lidar sensor. On the upper right side you have a camera image for reference, and these plots here are the data from the weather sensors. So on the bottom right here we have our precipitation intensity, that's this curve here, and you see it fluctuates, goes a little bit up and down, and on the right side here it goes down to almost zero, right behind me here. And we have a couple of peaks. This one, for example, goes almost up to 50 millimeters per hour, so that's quite intense rain we have here. On the top part, this is the drop size distribution that we measure. And here we have the meteorological optical range, so basically the visibility that we have from our visibility sensor. If we now have a look at the point cloud, you see this is the base here, where we have the lidars connected and the weather sensors. And on the other side back here, you can see the target area. And if I play this back now, you see all the noise here. And this noise actually comes from the rain in this case. If I go down here, you see all these points in the atmosphere. Those are all detections from raindrops, so atmospheric detections. And we use these points as a metric, a KPI, to quantify how the rain affects the lidar. and we can take a filter volume. So we filter out all these points in the atmosphere where there's nothing behind it, and we can count them. And if we do that, we get something like this. So this is an example of one measurement where you have the precipitation intensity in orange, and you have the number of points, the number of detections in the atmosphere in blue here. And you see that it nicely follows, and you see the direct correlation between the rain intensity and the number of points you have in the atmosphere. And now we can take a bunch of these measurements, a whole lot of these measurements that are automatically recorded, and we get these combinations of points. So we get one intensity value for the precipitation intensity and one value from the sensor, the number of detections in the atmosphere. And we can aggregate that over a whole lot of measurements and sort that by intensity, and then we get these kind of curves. So you have the precipitation intensity of one axis and the number of detections in the atmosphere on the other axis. And every single blue point you see here is one time step of one measurement with the weather test bench. And then you can get your average values here, 50% percentile, 25, 75, and so on. So you can get an actual performance curve of how that particular sensor performs in different weather conditions. And this is what you can use to compare that to your simulation. You set your simulation to, let's say, 25 millimeters per hour rain intensity, and you can see if your simulation is somewhat in the bandwidth of the measurements you have. Of course, there will be outliers due to a couple of reasons. One is the weather changes quite fast. So you have areas like this where it's not quite matching. Also, weather effects like rain, they're not homogeneous. So we measure the rain intensity at the station, directly at the sensor, but 20 meters, 30 meters, 50 meters in front of the sensor, it can be slightly different. And that's why you also have these variations here. And then of course there's the drop size distribution that's not factored in here in this plot. We can factor this in because we measure it. And then we can have different performance curves like this for different drop size distributions. But that's also a factor why you have a couple of outliers in here. That's why it's important to take a lot of measurements. And we do that automated. So this kind of means out, the outliers filter out during the course of several measurements. And you can get the mean value here. And you can use that to validate your sensor model. That's it about weather measurements. Of course, we can do the same for fog, for snow, and so on. It's the same principle. And if you have any questions about that, if you need more information, check out the link in the description to our website for the weather measurements. And if you're interested in putting your own sensor on the station, we basically rent out spots on that station for your own sensor, and we do a campaign over several months to take automated data. Feel free to reach out, check out our website, and see you in the next video.